Another way that we can measure position is by using something called percentiles. So we're going to talk about percentiles and we're going to talk about quartiles. And if you would think of them as pennies and quarters, I think that would be very helpful. I'll help you remember. So percentiles are used when you're ranking and you want to know where you fall within a group. A lot of times standardized test scores, you'll receive a percentile, like maybe you scored in the 80th percentile or P80 on a test. Sometimes class ranks can be given as percentiles, but percentiles are slightly different than percents. When you have a baby, the first thing that they do is they measure their head circumference, their height, and their weight, and they will give you a percentile for each of those. So if your child is in the 90th percentile for weight, what that means is 90% of babies the same age weigh less than your baby, and 10% would weigh more. So that gives you a feel for if your baby's on the heavy end or the lighter end. If your baby was in the 10th percentile, that would mean 10% of all babies weigh less than yours. Okay, so that kind of gives you a feel. So the percentile is, we write it P sub K, where that's the number that's the percentile. And that always indicates, it says K% of the data points are less than or equal to that value. So whatever that number is, that's the percent below your particular data point. So they're like pennies. There's 100 of them. So they separate the data into 100 little percents. So your smallest data value is down here. Largest data value is up here. We never really talk about P100, but that's what this would be. So you can see that P1, this would indicate the bottom 1%. P99, that would kind of separate out the top 1%. Or you could talk about the bottom 2% or the top 2%, but they each correspond to a number from 1 up to 99. Okay, so that's the way percentiles work. And I've got a couple other examples in here. So if someone's SAT math score is a 600, and they realized, or they were told that they fell in the 74th percentile. So they said, oh, hey, you're P74. The score of 600 is the 74th percentile. What does that mean? Well, that means you did better than 74% of the test takers. But that also means there's some that did better than you. So it means that 74% of all of the SAT math scores are less than or equal to yours. And so then what would that other percent be? If you've got 74 below, then the amount above would be what, 26? 26% of SAT math scores were greater than yours. So it just sort of tells you that, you did better, way better than the majority. That's a pretty good place to land as P74. Quartiles are the same thing except quarters, right? So there's less of them. You have Q1, Q2, and Q3. Q1 is the same thing as P25. Q2 is the same thing as P50. Like if you had 2 quarters, you'd have 50 cents. It's also called the median, right? Because it splits your data. If it's the 50th percentile, it splits your data in half. And then Q3 would be the same thing as P75. So if you understand percentiles, then you can understand quartiles. But we like to split data into 4 equal chunks. You can see there's 25% in each one, because that ends up becoming useful with the next topic we're going to talk about, which is how you're going to measure deviation. We already talked about standard deviation, but there's another one, and we're going to talk about it here just a little bit. And it involves quartiles. Before you calculate percentiles or quartiles, you have to have your data sorted from low to high. The data has to go in order. So if you remember, the other thing that we calculated where your data had to be in order was the median. So when you start talking about medians, quartiles kind of are in the same vein as medians. And let's say the only skill you had no calculator, the only skill you had was you knew how to calculate a median, because you can like walk your fingers in to find the median. So how can we find Q1, Q2, and Q3 if our only skill is finding a median? So here's a quick example we're going to do just by hand. It says the following 13 data points are sorted final exam grades of a sample of students who took the stats final in 2005. This is actual data from one of my classes, but it's old data. It says calculate Q1, Q2, and Q3. So the first thing you want to notice is that you have an odd number, which means you will have an actual middle. So let's start by finding Q2 because that's the same as the median. So all I'm going to do is use my fingers and I'm going to walk my way in, and I know I'm going to have an exact middle, and right there, that's Q2, which is also the median. And you can see how many data points are before. 1, 2, 3, 4, 5. You have 6 data points before, and you have 6 data points after. So that is the halfway mark. It splits your data right in half, okay? 6 on one side, 6 on the other. Now, if the only skill you have is a median, how would you figure out where Q1 falls? Wouldn't Q1 have to be halfway on the left side? So you would just cover up your median and take those 6 and find the median of those, and that'll give you Q1. Now there's 6, it's even, so that means we're going to have to average the middle two. So if I walk my way in, I'm going to have to average these, and maybe you can do this one without your calculator. What's halfway between 64 and 66? Well, it would be 65. That's Q1. Q1 would be 65. And so you have, to the left of it is 3 data points. To the right of it is 10 data points. So since Q1 cuts off 25%, 3 data points should be about 25%. Let's see. 3 out of 13. That's pretty close. It's not going to be perfect because we only have 13 data points, so we're going to have to do some rounding. But that's pretty darn close. That's the best you're going to get with a number like 13. So now let's cover up the median back, and let's do the same thing over here on the right side. We're going to find Q3, so we're going to walk our way in. Now this one we might need to average on the calculator. What's halfway between 84 and 87? Let's see. 84 plus 87 divided by 2. Just run a quick average. 85.5. That's Q3. And you have 3 data points above it, and you have the rest of the data below it. So that should be 75% of the data below it. And it's close to 75%. Okay, so if you only knew how to do a median, then that's how you would find them. But if you had a ton of data, it would be much easier to just use the calculator. And you already know where to find it on the calculator. You go to 1VAR-Stats. I mean, this is no big surprise. 1VAR-Stats is where all of your statistics are. And at the bottom of 1VAR-Stats, you may remember that there were some Qs in there, and you probably didn't understand what they were at the time. And now you know that those are quartiles. So with our quartiles, we can calculate what's called the inner quartile range. And this measures variation or deviation or spread. So the interpretation is the more spread out a data set is, the higher the IQR will be. So a big IQR means really spread out. A small IQR means it's very tightly clustered. So this is a good measure for deviation or dispersion or variation. Is going to be kind of a competitor to standard deviation. So we have standard deviation and IQR that are going to measure spread. We have mean and median that measure the center. So how do you get the IQR? It's this little formula right here. It is literally the range of the middle 50%. So if we go back to this picture, if you look at the distance from Q1 over to Q3, do you see how that's the middle 50%? Okay, we want to know how wide is that. That's what IQR is. It's how wide that is. And you take the high minus the low. So that's why it's an inner quartile range. It's range, high minus low, and we're dealing with quartiles. And it's the interquartile, so it's the ones in the middle. So the name itself kind of tells you what it is. That distance, that's IQR. You don't have to memorize the formula. It'll be on your provided formula chart that you're going to get on every test. So for the last example, I just put it away again. Let me see. If we wanted to do the IQR for that last example, we would do Q3 minus Q1, and Q3 was 85.5, and Q1 was 65. So all we have to do is subtract, and we can figure out what the spread is of that middle 50%. So 85.5 minus 65, we have a spread of 20.5 points. So that middle 50% of test takers had a spread of about 20.5 points. Now, is that big or small? Well, I don't know. It seems kind of big, but unless I could compare it to another class, it's kind of hard to determine big or small if you don't have anything to compare to. All right, so this is going to lead into the concept of outliers. And now we're going to be able to actually figure out definitively if a data point is actually an outlier or if it's maybe just an extreme value, but not technically an outlier. So the way that you're going to check for outliers is you are going to create some fences, okay? And I'm going to try to draw you kind of a little picture in here, okay? So the first thing you do is you calculate Q1 and Q3, and if you wanted to put them on a number line, you could. So I'm going to make it kind of small here. Let's say this is Q1, and let's say Q3 is right there. So we're looking at this distance as our IQR, that distance right there. The way that you create these fences is you take that IQR, which is about the width of my finger there. Take that IQR, you want to add 1.5 of those up from Q3 to create your upper fence. So you're going to start on Q3 and you're going to go up 1.5 of those. So if I go up 1 and then 1/2, it would put it, well, I don't know. This is not an awesome measuring tool that I'm using here. I am literally using my finger. I don't know, it would put it like maybe here. So I'll call that upper fence. And then you're going to play the same game, but you're going to go down from Q1. You're going to go down 1.5, and it would put you, I don't know, about right there. We're going to call that the lower fence. Why is it 1.5? Honestly, I don't know. It's whoever came up with this, whatever statistician is credited with doing this, that's what they decided. You go up 1.5. So 1.5 up from Q3 and 1.5 down from Q1 creates those fences. And then you want to think about it. That's like your yard. So if somebody is not inside your yard, if they lie outside of your fence, then they're an outlier because they lie outside. So you're going to have all these data points scattered within here on this number line, and anything within the fences is perfectly fine. But the second you get a data point that lies outside of the fence on either end, that would be considered an outlier. So that's our definition for outlier. If a data value is less than the lower fence or greater than the upper fence, it's an outlier.